I wonder if that makes a difference. Probably. Yes, that should do it. Let's see here. I wonder if that makes a difference. Probably. Yes, that should. There we go. So, let's just jump into it and see. Yeah, that meme, huh? Last time we made it so we generated a bunch of units. So we have an RTS game where we supposed to be able to run around with this guy that we have right here, like a normal third-person game, and then press one button and go into RTS mode and be able to control a bunch of units and be able to switch between those. And the thing that we did last time was to work on the selection of the units. So that means, hey, Skalzam, welcome back. So you can see here I can move around. Very, very primitive movement system, but that's not the focus right now. And then we have 2 guys here, and I think we have a bunch of other guys. So they spawn a bunch of random guys all over the map to test with. But so we are going to go into. We took all these units, and then we converted their world position into screen position. And that is, normally a Unity, default Unity camera operation that you can do. You can just say camera dot convert world point into screen point or something like that. But we did it, quote unquote, properly in DOTS in a way that is way, way more efficient. So let's just go over that real quick. So here we have the selection UI CS script. It's a system. Like the system dot system, and it will go through all of our units in this for each loop, and it will take their position and it will convert this position into screen position right here. So the screen coordinates that comes out right here, those are the actual screen coordinates of the object. And we do this paralleled and burst compiler, which makes it super, super fast. So that was the thing that we did last time. Now I have 2 goals. So just FYI, 6 p.m. GMT is in 2 hours. You are completely correct. Huh. Brain fart. Brain fart. I wonder if I should. Yeah. I feel like I should stick to my schedule. I feel like an idiot now to be able to have to shut this stuff down for 2 hours and then start again. I don't know, Sam or somebody else in the chat, can you say if it would be okay to push it 2 hours further? Maybe nobody more will join in at that time, or maybe we should just run with it. I don't know. That was, yeah. It's 6 o'clock in Sweden right now where I live, and I've used GMT all the time, and today I didn't realize that. I didn't remember to actually think about the difference between GMT and our local time. So that was goddamn annoying. But I have one guy, I think, who's probably waiting for this time. So you know what? I'm gonna be annoying, and I'm gonna actually I'm here so I don't mind. Oh, you mean yeah, it's a really delayed chat. But do you mind if I push it 2 hours later? Because I think there's one person I saw somewhere write to me, and he wanted really to see the next one, and I don't know if he realized it's on right now. So, or maybe they can just watch the record, the DVR or DV, whatever they're recording. That could be a thing, actually. Yeah. You know what? It's all right. You can just reverse it if you realize it's wrong. So let's just let's jump back into it here. So oh right, it's you. Ah yeah, nice. Let me just see here. Yes. Good. Let's go. I'm very excited about doing this. So we did this thing where we converted everything into screen coordinates, so I wanna use the drag selection box to actually see stuff inside my and compare to the screen position and see what happens when we and see if I can count how many we are selecting. I think that would be fine. So right here in the system selection systems thing, we have we already have all the data screen buffered. Man, I got really thrown off there for a second. I need to restart myself, and I need to do like this. It's Friday evening after all. So, we should take the screen positions and compare them to the drag thing, and see how many we have inside of our box. That's what I wanted to say. So, right now we just write them out like this, but let's do some comparing. We have our selection somewhere. I don't remember where we put it. Dragging. Oh, we have it right here. So it's an UI. We need to put this data of the drag box into this system, right? So that should probably be quite easy, but we can just have a reference to this game object inside our system. It's not a big deal actually. Public selection, like that, and then we can have a void start. So you can just do world dot default game object injection world. I don't know why they have this big long name, because they want to make sure you use that for just injecting like game objects, traditional game objects, into the system, because this one can be accessed from basically anywhere, and you can do it through you can do it so you can push in stuff, game objects, into ECS wherever you want, like right in the start phase, via this access to a specific world. So a question here, Ravanin, a little question. I understand that dots is great with values, but what about strings? Is it good for parsing? Like if you want to make a very complete dialogue system, could you use dots? So that is a good question. So dots, yeah, strings is tricky, and they're tricky for quite obvious reasons, but also weird reasons. One of the weird and almost annoying things about C# and Unity is that this thing that everybody who works with Unity and C# and doesn't have a lot of experience with other languages, they sort of assume this thing where strings are just magical baseline objects that exist everywhere, and you can like toString is always something available, right? And that is super nice, very good feature, but it doesn't jive well with performance at all. And C# sort of like put this whole machinery of string management inside of their language, and they probably optimize it as well as they can, but it's like whenever you're dealing with string in C#, you're often just throwing around garbage, like memory that's gonna be garbage collected eventually, and you're doing all of these random things with memory just to do some string operations. And it's like almost, I feel like all of the memory stuff is almost hidden behind this, string X plus string Y. That thing generates garbage. If you do that every frame, you will have lag spikes in your Unity game. That's just the way it works. And cheers. Sour beer, favorite. So, to answer the question, a dialogue system is inherently not like a big number and data crunching system, right? It's more or less data relation system. So you have a bunch of data, which is your dialogues, and you want to relate them to each other in different way by whatever button the player presses or something, if you want to have branching stuff, and that sort of connections everywhere. Like there's nothing preventing you from coding that in DOTS for sure. But if I would do it with my experience with DOTS, I would probably do it in DOTS because I want to keep it clean and just have everything DOTS. But I would almost like recommend somebody who's new at it to not bother making a dialogue system of all things in DOTS, because you're not going to get very much benefit from it unless you have 100,000 dialogue lines that you need to crunch, or 10,000 that you need to crunch like every frame. Then you have a big, huge advantage of DOTS. But otherwise, it will just probably, for somebody new, be really annoying to try to program it in DOTS, because it's just structs in DOTS mostly, and juggling the actual data when everything is structs and fixed arrays, not fixed arrays, but sort of fixed arrays, juggling everything around and moving through dialogue. It's maybe you want to remap dialogue or whatever. It's just a tricky thing to do, I think. It's tricky in normal C#, and it will be more tricky in DOTS, in my perspective. Well, if you want to try it, I think it's a valid thing to do. It's just that it's not going to be easier. I hope that answers your question. And this is interesting. I can pick up our main project here and have in-world text system. So this is our in-world text system. It shuffles out a string to a TextMesh Pro in-world text, and the text is generated by either a native string or fixed string. And these are just inherently different ways of working with strings, but you can look at them as building blocks of strings that never changes. But you can so to speak, put building blocks together. They will still be individual blocks, but they will be together. So you can have character health, and then you have all the numbers 0 to 99 or 0 to 100 generated somewhere, and that's the actual health value. And then you have character health and the value you want to have, and then you put them together. And by having all of the different combinations of number already generated, and then just marrying the two strings with something like native string, that's one way of dealing with this. Because otherwise, if you're gonna do two string, you're gonna generate garbage, and that's just don't do it in DOTS. So you can see here in this code, I have these stuff: single, double, and colon. I don't know if you spelled that actually. All of these, and this is just to have the 0 somewhere, so I can pick it out, because otherwise it will be generated for me when I use this quote unquote 0. And then so these are the systems that you're gonna be using, and they are you can look up the documentation for native string and for fixed string and see for yourself. They have completely different way of working with it, with strings, but they can achieve more or less the same thing depending on what type of string manipulation you want to do. So one thing I saw on the animation rigging is that they recommend not to change the effectors instead of repaint them. Maybe that was typo, I don't know, because they use jobs. I don't know. That's new to me. I haven't worked much. I have actually not worked with animation rigging in DOTS basically at all. The old animation system has old. I don't know if you should call it old, but the traditional animation system is you can actually drive that with a job, and I've done that. The last game I worked in, Batterite, which was released 2016, I think. We worked on the animation rig system for that in 2015, and back then I think, if I don't remember it wrong, you could like actually drive animations without, you know, the traditional just setting animation. I don't know why I'm going into this. Never mind. It doesn't matter. Reparent. Affect. Yeah. I'm not going to be able to answer that. That's effectors. I haven't worked with that. So string could not work well. String can works in job very well if you use any of these two. There's a third one which I haven't explored because it's weird. But with these two you can. And like I said, the documentation will show you, and you will, when you come from C# strings, you will be annoyed at this. But it's like going back to C++ and working with strings. It's annoying because C# made it so easy to work with strings, but also like it's very costly. I had games with just like a single 2-string somewhere deep in the system which ran several times a frame, and I had major lags because of it, because it generates garbage and it piles up, and then eventually the garbage collection can trigger, and bam, you got a small spike. So there's certainly drawbacks with having the easy string manipulation the C# has. All right, let's backtrack. We wanted to put in the reference to the dragging box into our system so we can use it to select our units, right? So we can do get world, get system, get or create system, my bad, and then selection drag system. So I'm going to explain like really quickly what this means. This. Thanks for the detailed answer. Yeah. If I come up with anything more, I will blab that out as well. But yeah, that should be. I was really annoyed myself when I started working with that in our big game, because it's like, holy shit, so much code just to draw like open the door. Yeah. So world is a static thing where you can access a bunch of different stuff. A bunch of stuff is also like going extinct inside of here, I think. But this one is like purposefully made to access the world from anywhere outside of the ECS systems. And it's mostly for start, when you want to inject something traditional Unity into a system. So here we have this one, you know, will be instantiated somewhere in the scene, and will start up, and then will put itself into this system right here. And now we have the information, the squares and stuff, and we could probably so we want to look at we want to compare this value, this dragging box, to the actual value, and I just want to look at what type of value we're looking at, because either it's from -1 to 1, or it's from 0 to the screen resolution, and I don't remember. So here we have the on-screen data, and that is in screen resolution. Maybe we should actually convert this to -1 to 0 resolution. I don't remember. Let's see here. Let's have a look at the dragging box. That should be quite easy, I think. So let's press play. Oh, I spilled. Give me a second. I didn't even realize that I spilled. So here we have this, and then we can go up tab, and we can should be able to drag, but we can't apparently. So let's check that out. Maybe it's something here. Yeah, it's probably that. We have the native array cannot be disposed because it was not allocated with the allocator. Huh. Oh, right. We are. This is interesting actually. So remember how we produce our screen coordinates here for all the units, and we put them in this native array. Oh no, it's yeah, I was gonna say that we need to dispose of them properly, because we are picking them up in a later part of the frame. When this scheduled job is over, we're picking them up right here in this group, which is later in the frame, right? This is in initialize group in the start of the frame, and this is in the middle of the frame, and we're picking up the result. But then we're also disposing of them here. And the thing what they are complaining about, if you look here, the manage function, blah blah, no, this one, the native array cannot be disposed because it was not allocated with a valid allocator. That means basically we're trying to dispose of an array that hasn't been created. So this means that this thing probably gets run once without we having ever set the buffer to anything. So that means we basically need to do if is created. And we can even do like this, we can put the whole thing, because there's not much selection going on if you don't have any screen positions to select on. So yeah, that's that. Let's see here. We want to take a look at this. I'm going to comment this out first just to be sure, because I want to have a look. The managed function Unity engine shrim manager dot get screen shrim. I have no idea what this means. Like, if somebody in the chat have ever seen this before, please tell me, because I've never seen it. 93. Gotta be some error. Gotta be something weird. Dots, jobs, leak detection, burst, everything should be, yeah. So, let's see here what we can get. Yeah, that is strange actually, burst error. At selection UI 93. Oh, holy shit, what a damn. So here we can see another teaching moment because I'm stupid, but that's good. So for some reason last time I put the screen coordinates straight here into the calculation inside schedule parallel. So this is like a blatantly obvious race condition problem where, you know, if we change the width or the height of the screen while this stuff is running in another thread, obviously this access would be like, hey, what, width is 0 now, why? And then everything will break because if stuff doesn't go in defined order, you know, everything can break for any reason. Like, race conditions are extremely tricky to diagnose, and Unity with dots, that's one of its biggest strengths, has sort of fixed race conditions in this place. There's a lot of languages which helps you a lot with this, like Rust, for example, doesn't like exist race conditions in Rust, I believe, but in C# with Unity dots, they have actually like made it so you can program and you don't need to care about race conditions, because unless you're doing advanced stuff, because they are going to say like, hey, you're in a scheduled parallel, this is going to go in another thread, and you're accessing a static reference to something. This static reference can be changed by anything else because it's static. It's like, you know, it's a static variable. So Nana, you cannot access a static variable inside of a scheduled job. So the only thing we need to do is put in a copy of this. That's it, because the copies get captured by the dot system, and then they go into the job, into their own thread, and nothing happens to it, and they get discarded afterwards. Probably on screen with, yeah, Skadsam. Maybe that was basic for you guys, but now you know. Should probably be able to do something now. shim. I don't know why it said shim there. And let's go up. What have I done? Screen selection square. Oh, I had it. Yeah. So you can see now we're gonna use this, and if we take a look at the screen positions and everything, we can see that we have values here which are, you know, in screen coordinates or something like that. But I actually want to have both of them in -1 to 1 in both one, because it's like then all the calculation will never care about the width and height of your resolution. And like obviously you can push in the screen resolution in every function that needs it, but this way we can be like agnostic about screen resolution, and I think that's a good idea. So let's convert this thing. We have this square that we are dragging out, size delta, that's yeah. Let's just have a quick look again so I can just know. Where I'm going with this. So if we look at that and then we take a look at this square like that and like that. So this square is actually, you know, it's a little bit tricky because this square has its damn midpoint in like the mid of this. So I need to calculate both this point and then pull it into the other range, -1 to 1. So -1 and 1. So that should be like, first of all, finding that point and then going from there, which means taking the mid position. Oh, that's the this position actually, and then this is the end position. So that's pretty easy. It's just the visuals that actually needs this conversion right here. So we can just take these two and export them. So that should be like, so right here it's a bit nice because, you know, you can do a vector2 dot start point and then end point, and like hide in inspector because this is, or non-serialized, I mean, like that, because this is not something that we need to care about. We set every frame, so that should be, you know, the start point should be whenever we put this in, and I'm using doubles of these because I just want to have them like separated, because obviously start point and underscore position is going to be exact same value. And then the endpoint, oh my bad, like that. And then the endpoint should be something like this. So now the start endpoint is like these two positions on the screen in screen coordinates. So if we and I believe it should be like, let's see here. Let's just have a. I always forget like where is 0, 0? Is it down or is it up on the left side of the screen? Is it good idea working with C# structs and Unity native structs? Unity native structs. I'm not sure what you do. You mean like native collections? Native structs. I feel maybe I missed something here, but I never heard of that. Yeah, screen me not bottom right, left. Yeah. There seems to be an Unicode. I think it can be used with chars. Native strings. Oh, yeah. Like this whole discussion about working with like structs and dots, structs and Unity dots and native string and everything. It honestly is more or less about the right tool for the right job. Like if you have the time and you're really interested in it,
sure, you can do it for like whatever project you want. It's like if you make it work with native strings or fixed strings, it will always be faster, more or less, because it's just the way that the garbage collector works. And the like if you have a string that a variable that points to a specific string, or a string, it's by default class a pointer, and pointers are not magic. When you access them, you will still access the memory wherever it is, and it might not be in either of the caches on your CPU, and then you're fucked. Then you're gonna spend a bunch of time getting that, and that's what mostly slows stuff down. So instead, with native string, that could be the case as well. But the thing is that you're not like sending this variable into functions to use it all the way straight in and then getting it from memory. As soon as you like touch the variable, it will like load sort of into memory. So that means that you can more easily know what memory you're actually having in your presence fast access, because a class that you just a class variable that just send in a bunch of times in a few deep down in your function stack, and then all the way down, and you access one little variable from it. That can be a huge hit on memory access, and that doesn't really happen in the same way with structs, because whenever you go into a function with a struct, you're gonna copy this stuff in, and that will mean it will will access to it. Yeah, I would, like I said, I would, if it were like really performant, you know what? I would probably try and like getting a little bit familiar with the native strings thing, fixed strings, see how they work, and see like try to solve the like top 3 things you have in your head that are like actual problems. Try to solve them just on paper, not on paper, but in code, in just random test cases, and just see how it looks, and see, is this reasonable, or is this gonna be like wall of text just because I can't use normal strings? And if you're like, yeah, this is just stupid, it's just walls of text for like maybe, I don't know how many % improvement of the performance, maybe it's not necessary, and you're like, screw this, I'm never going to be finished with the game if I keep doing this. And that's what I meant with the right tool for that right job. If you're making a small game, you don't have that much time, or you're not that interesting, screw it. It's like one of the last thing you should convert to dots in my mind. Alright. Now yeah, keep the question going. Hopefully you other people who are not asking the specific question are not too bored. I think it's interesting questions, so I like to answer them. So we were looking, I just wanted to take a look at, like, if I do like this, let me just enable this. If I do like this, god damn it. Like my x is more or less, yeah, oh, yeah. So they are minus. And if I just, sorry, my bad. Wasn't really. I just want to make sure I know which is the max and the minimum value. If it's like negative anywhere. So just debug log. And this is obviously trivial for a lot of people, and sort of including me, but one thing you learn from several years of experience is that it's often more effective to just like make sure you're aware of whatever you're working with and everything, how it looks, before you assume anything and try to program with it, because then you're going to be like a couple of logic steps above it, and then what's happening, and in the beginning was just the value was in the wrong format, and that's just annoying. So yeah. So like it's like 0 0 down there. Yeah. So that's good. So it's 0 0, and I knew that the mouse position started at 0 0 down to the left. I wouldn't bother trying to figure out the UI coordinates at all. You have the start and the end coordinates. Yeah, that's a valid point, truly. But now I'm sure wherever this is. And actually, it's a little bit mind tricky when you're streaming, because you're like, wait a minute, am I thinking of everything here? Am I going to look like an idiot in 2 minutes because I don't think about this? And the chat is delayed enough, so I can't really expect you guys to catch me in time, and I don't look at that all the time. So it's gonna be look a little bit newbie-ish when I do this type of thing, because I want to make sure I don't do it wrong. So let's convert this to we can just var start point equals to start point, and then let's take the endpoint and let's convert this. So that means that we would want to we can just convert these values, not create new ones. So this means that we should make it the x should be width divided by width, and the y should be divided by height. We can just do this actually. And then we have the same thing for the endpoint. So now we have 0 to 1, right? And now we're gonna take both of them and do like times 2. So we get 0 to 2, and then take both of them and take it minus 1, right? That should be the correct way, right? Like I said, my brain just math, structural and stuff, and explaining, that's totally fine with me in real time with the chat and stuff, but math, just like my brain just like and I've been doing this for so many years, so it's like, why is this happening right like this right now? Anyway, screw it, let's just try it. So this means like, so whatever I do, this is a good recommendation, maybe everybody does this, whenever I am in this situation, I just like try like 2 or 3 different values in my head and go through the transformation and see wherever I look. And obviously that's like code review basically, but just like, okay, so let's say x is all the way to the left, 0. So we have 0 divided by whatever, 0, and then we have that point times 2, so it's 0, and then we have minus 1 in the end here, and that becomes minus 1 on the left side. So that's correct. And then we have like maximum width all the way to the right, like say 500 in width, and divided by 500, so we have 1, and then we take times 2, which makes it 2, and then minus 1, which takes us back to 1. So start and end point is the right value. Cheers. Whatever you do, don't do it live. I don't know exactly what maybe I don't remember what I even said to you guys, but anyway. So we have the start and the end, and we should just compare it. And like now we don't really need to use this thing. The screen coordinates are actually we don't need these values at all right here, because here is where we are producing. You know what? So my original thought was to produce all the proper screen positions right here in this thing and then compare them right here. Well, what's the point of that? We can already know if they are inside or not. Right, the first thing we do straight when we get the screen coordinates values done, right? So, and I'm just gonna take a look at these values once again.
debug. So we can just spit out like this is all the entities that is inside your selection, and that can be it, because we can do everything in parallel in our own thread. So now I just want to make sure that that these screen coordinates without this transformation is on the right point, like -1 to 1. All right. Oh, I don't know if this is anywhere outside of Sweden. No, it's made in Sweden actually. Sour beer, highly recommended. Oh my god, I'm not a beer person, but sour beer, it's like your jaw is like just freezing up because it's so sour. I love it. Strange. Anyway, let's take a look here. So I just want to make sure that the values, that the stuff we are putting out is in the right. Oh, my bad. You see, this is, the text manipulation thing in C# is so good that stuff that even barely makes sense as text, like a struct, like what's that supposed to be? And C# just spits out everything, the name of it and everything, like the name of it in code. That's just like very, very nice to have, but we are spoiled with that sort of feature. In C++, everything just like, you're stupid, let's crash. That's the response you get. So that seems to actually, because I think it's like let's just have oh wait a minute, do we have one more? We have 2, so let's just have 1, so we just see the values from 1. So it looks promising actually. Looks very promising. So if we go up here, there is the guy, and if we go all the way here, the values are approaching -1, and that is what we want. So that means that it's in the proper, let's just, to be sure, check the right corner as well. So like I said, so I don't look stupid in 2 minutes when I try to use it. That is, yeah, that looks exactly. Yeah, it's perfect. So we have the right value. So now, remember the first, the other stream when I said like, oh, here you have all the native array with all the screen position, you can consume it and do stuff with it. So having the screen position array, screen position values for all the units can be useful. So we might as well let that be here, but we're not going to use it actually. Not like that anyway. So let's do like this instead. Public bool selected, right? So let's calculate the selection inside of here instead, and we can do like this, because we know that this code is going to transform our coordinates into like the actual resolution. So if we do our inside the box selection code right here before the conversion, then we can have both. So I guess this would be something like this: screen coordinates dot x is bigger than start position dot x, and same goes for the y value. Maybe I'm missing some obvious syntax trick here to make this a little bit shorter, but it's clear and I like it. So, and then the x and y value is supposed to be lower than the endpoint. And like right now we're always dragging. I once tasted raspberry beer, it's pretty good. Yeah, raspberry beer. That's probably just normal beer with raspberry flavor. Probably pretty good, but sour, I recommend trying that. That's something different.
All right, we should have our function here that actually like sees if stuff is inside of the square. And let's just do it like this then. Bool var selected goes to false. I am aware that you could just take this whole if statement and put the result into this instead. But this way it's actually like quite clear. No, actually not. It's not that much different. So we're gonna do like this. So just put that like that instead. So obviously that's the same thing. If everything is inside of everything else, then we are selected, and we can do like that. So now we will have everything selected, tagged selected, which is selected. Selected. And we can try this out by just having some sort of a counter here. So var counter equals to 0 for each length, and then if this stuff is selected, then counter plus. And then we do print this stuff. So, like, probably obvious for everybody here, but if somebody aren't familiar with it, this thing generates garbage, like not an insignificant amount. So, and it's this plus is the culprit. C# just like, oh, everything's fine, you can do anything you want, just go ahead. And then when the garbage collector kicks in, like, oh, but screw you. Anyway, now if we take our spawner and we add like, let's say 100 units, and we push play, let's see here what happens. I don't know if it's gonna work, but I think it should. So now we have 0 selected, right? Let's activate our selection square, go into tab, and then, oops, my bad. And then do this. But we have an interesting problem where we have more selected than we have characters on screen, I think. But you can see here how when I go over, you see the counter goes back to 0. And then when I go back to the guys, I get the... So that's interesting. 2, 3, 4, 5, 6, 7. I get 100 selections there from nowhere. I don't know why that is. Something is generated 100 of at 0 point. That's probably it. So like, this is also an interesting thing here. So you see how, I don't know if could use Unity rect class. It's a struct, but yeah, rect class. That's a good point actually. Man, my brain is obviously not on point today. That is such an obvious thing. But also, to be fair, it's quite easy to just think of it like in terms of just floats like this, because then it's like it's very obvious the actual math and the manipulation that goes into it. But like obviously rect is much easier because it has the contains function, I believe, if I don't remember. So you on my if statement that checks if everything is inside, that is just a function that Unity already did for you. So I will convert that for sure. That's a good idea. Anyway, this is interesting. So I believe this is it's because I have for some reason like 100 units spawned in the goddamn middle. And this is interesting because that means that we have a bunch of invisible objects. No, we don't have them invisible. I just realized what is going on here. So if we take a look at this situation right here,
we have, where is it at? 0, 0, there we go. So probably like one of these guys has like 1,100 copies of himself underneath, so they all just stand on 0, 0, 0. That would be my guess actually, or maybe not, I don't know, we'll see. But anyway, this is obviously just bonkers that we get 100 people added to the selection just because we are selecting 0, 0. So that means that I want to check and see how many we actually have here. Let's do something like this. But yeah, I'm gonna show something interesting later to just make sure that people understand why this is interesting, what I'm doing. That sounded pretty pretentious, but why this matters to do this type of thing. I just realized because we should compare this, or not compare, but we should look at the performance of this we already have. Okay, so there's 200 of them. So for some, we are spawning 200 in the spawner of spawner, debug spawner probably. Yeah, that's debug spawner. Oh, yes, that was a big goddamn mistake by me. Let's do it like this. So when I moved over the code, I couldn't spawn everything in convert, so I moved it over to the first update of the system. I forgot to take away the old spawner, so yeah, well, fun times. But let's do something like this. Because now probably this will work. Let's just make sure. So one print every frame is not a big deal. It's gonna take a few microseconds to do it, but it's still not a big deal. But having 10,000 of these guys on the screen, each frame, and then oops, my bad. God damn it. Having 10,000 of them on frame on the screen and then dragging, that would just basically not work in normal Unity, because getting that thing, that transformation of the coordinates working that fast is not impossible, but close to it. So if we go up here and we do like this, yeah, now everything works and we're getting whatever. So you can see here, count 53. So let's just do this. Let's take the controller for the camera. Where did I put it? Here. And let's just like disable it for now, because scrolling around, that's one of those things that you really need to tweak a lot before you get the good feeling of an RTS, right? Because just shooting away at one of the sides whenever you all the time when you don't want to, that's annoying. You can see how I keep being annoyed by just getting tracked all around with the camera, and just to make this selection test easier. So a lot of half-assed words. Let's see here. So there we go. Now we can take a look at this, and let's do this. Now we're gonna have fun. So 10,000. Do people think that we're gonna be able to pull this off? 10,000. It's not even like a lot of code. It's just very basic code if you just know what you're looking at. And there's like nowhere that I would consider this being an optimized thing. It's just like normal DOTS code. And let's push 10,000 guys on this. It's going to be just like a wall of guys, right? And units, and then select them and see what happens. We can have this turned on, by the way, from the start. It's going to take a few seconds to load because we're trying to spawn 10,000 of them. There we go. That looks nice, right? Let's just have a look here. So printing this, drawing this with the graphics card is not a big deal because they're instanced and stuff, and that's optimized from the Unity. I don't know how this would handle in traditional Unity, because this is something that, you know, is optimized by the Unity guys in low level code. But if we go here and then we do this, so we are actually only pushing 30 FPS right now, but having 7,000 units being picked up like this, it's pretty impressive to do that this fast. And there's probably some obvious more optimization that I forgot about. But as you can see, I don't think this will work pretty well in traditional Unity. This is just, yeah, you know, normal performance basically, and we can take a look at this in the profiler. That could be actually really interesting. So if we bring the profiler over here, you know what, we should do like this first. We should maximize and play and do the same thing, because the Unity editor with a lot of windows open actually takes quite a bit of performance if you don't. So let's do it like this. Bam. That didn't do much actually. So if we try that a little bit. So let's see what we are looking at here. So play loop. Yeah. Rendering takes more time than the selection, probably by far. So this is the straight up the interesting thing here. If we take the timeline and we look at this, so let's full screen it. I don't know if you can see this very well, but I'm going to explain what we were looking at, so you don't need to be able to read the text at least. So here you can see all of the different things that going on a timeline. So here's the start of the frame, and there's the end of the frame, and here you have the initialization part, and I can't really see actually. I think initialization is back here somewhere. Anyway, it doesn't really matter. So if we take jobs and expand that, there we go. Let's see if we can find our here. So this is funny actually, because I don't even think we can find our 10,000 selection of units. Let's do it like this. So if we take so this is also very, very good to know when you're working with dots. If you want to be able to identify the job, because the job gets transformed into something weird. I don't really know how it works. I think it's a P invoke to C++ technically. So you don't really know where it just gets named something generic, and you can't really identify your jobs. So if we name it selection, and I'm just using caps here because it's easier to find it then. So we can identify our job in the job list, and we can see how much time it takes to select a few thousand units out of 10,000. And it's probably not going to be even a tiny blip, like honestly, because I realize now that there's so much else that is probably going to take so much longer time than doing this simple data thing. So let me just pull this away for a second and then do it like this, and we can see here it says 8,800 selection out of 10,000, and let's pull this back. And let's clear it and sample it a few frames. There we go. And let's have a look here. So we should be able to see our job somewhere here on the initialization. Yeah, there we go. It's even better than I thought it would be. This is just ridiculous. So everything, all the selection is done in 0.65 milliseconds. I challenge anybody to do that in even 10 times
as slow in traditional Unity. And that's, well, it probably can be done in traditional Unity if you really try to, but this is just naive, straight up code just written. It's just written in a way that it's like, yeah, let's do it with dots in the proper way, but it's nothing like a proper optimized code. It's just that Unity made it properly optimized for you. So anybody who want to have a comment on that performance or challenge my notion, because I might be wrong. I haven't done an RTS game. I've done similar thing where similar operations are done, and you know, like it can be done in Unity traditionally, but this level of performance I've never seen outside of dots when I work. Like, yeah, it's very, very nice. So that means that we could actually make a game where selecting 10,000, it's like a trivial thing, and I think that's probably something fun to do. Let's move on with this. Oh, I tried pretty much the same thing in traditional Unity. It was bad. Yes. Thank you, Skatsam. It was bad. And that's just to make sure, because that's the point of this stream, or for me to have fun and learn, and you to learn, but to point out these small things. That's more or less because, you know, a normal camera, traditional Unity camera, has this world to screen point where you convert either to one, and that's it. This thing does this that I'm doing here. That's like literally what's behind that function. This one doing that random access into a class 10,000 times is just, it's unreasonable. It just doesn't fly. Doing this type of a thing where you just like doing everything in order and everything straight up once at a time in multi-threaded, that's the way to do this. Anyway, enough talk about that. So next thing, pretty much just next thing, I think we should explore indicating who is selected. So this is a bit interesting. I thought about this for like a few weeks since this idea arose, because Unity Engine UI is as you know, traditional Unity with mono behaviors, and drawing an indicator on each of these guys that's not going to work with the UI. It's going to lag like I don't know. We could do something with a custom shader or something where we do our own basic UI that does it much faster, because Unity UI is way optimized for completely different problem. The problem of doing nice layouts easy, not drawing easy layouts fast. That's completely different from the perspective of the requirements. So I believe they probably are doing something to reconcile this and be able to use Unity and a UI system together with DOTS framework, because people are gonna need that. But if we want to make a selection indicator on each guy that we have selected, we're probably gonna need some other solution for that, and I'm gonna show you that. So let's go into that. It was a good idea to drink this during stream, because I drink too little normally for my throat, but this is so good, so I drink it all the time. So what I'm thinking about is taking, if we take a look at this, one of these laser bots, and we pull them out here. So kudos to my colleague Klaus who made this. I think I mean they are not like a million polygons, but I like the art style quite a lot. They have a thing here on the back, and it was purposely put there to make stuff like this. So it's an individual rendered component, health light material. I'm thinking about doing so when they are selected, this one blinks. or something like that. My end goal is to make it so their health is indicated by how much they are shining and blinking when they are selected or something like that. So we can double purpose it. But right now we can just use it so when it's shining, when it's emitting light, it's selected. And the way we could do this is with material properties, because when we have 10,000 of these, we can't write like their individual like material properties somewhere, because material is a class. We can't access that inside of a job, and whatever we try to do that is traditional, naive Unity material manipulation, it will be too slow for 10,000 of these. Like maybe not in a clean environment on a good computer, but it's just not a good idea. So what we're gonna do is gonna use Unity DOTS new instantiated material property thingy. I don't know what to call it. I'm going to show you, and it's gonna be, I think you're gonna find this quite interesting because it's really powerful. So first of all, when this thing gets converted, all of these guys, you can see here in the what goes into the prefab, these get split up in individual entities. That's how they are drawn. And even just FYI, if you have a material, if you have a mesh with several submeshes, and obviously then you address them with material through several materials in this material array, they will also get split up in individual entities. So if you have an object with two submeshes and you convert that, that's going to end up as two entities where one of them is the parent to the other one. So if first I thought this would be like a submesh, and we would have to like get that submesh after it's like generated and then change stuff on it. But this is like an individual game object straight here, so we can just pick that up. So let's do that. Let's pick that stuff up, and the way we do that is by, and this can be done by like automatic authoring systems, but I feel like it's better to learn like the little bit longer road, but the more flexible road that you can take to do this type of stuff. So if we just, this is a normal mono behavior, so we take a public, I don't know, game object, and backlight, or health light maybe. And when we have that, we obviously just gonna pull that straight in here. And so bot health, everybody knows what that entails, right? Not a big deal. And then right here, what we can do is that we can, this is going to be converted, right? It's marked to be converted. Convert to entity. It has the convert to entity script on it. And that means that it will convert all of its parents, all of its children as well. So we can take the conversion system, get primary entity, and push this in. So what this does is that this has a directory of all the different stuff that's converted. And it knows, it might not be done converting yet, but it knows which entity this headlight object will be when it's converted. And note that this says get primary entity. That's because, as I said, when you have one game object with several materials, which specifies in several different submeshes, that single game object will be split up in several entities, and this function then will only get one of those entities. You can ask for other ones, but that's why it's primary, among other reasons, but that's one of the things. So we can push this into a normal variable here, and that will be an entity. And then let's do another struct here. This is the interesting part. Struct unit health light material data properties That's a mouthful, right? But I'm doing this because I'm myself very verbose when I code, even when I'm not on stream. And this code will be available, so why not have descriptive names? Unit health, light material properties. And then let's name something here called float selected. And let's do something like this. Material property. Floats. So, two things here. So first of all, for the people who already know what this is about, where this is heading, this is not the most simple way of doing it, because there already are material properties to basically do this. But this is more or less to show off how you would do this, because there's so much things you can do with it. So for anybody who is like, yeah, there's already these properties inside of a normal lit material, you can push to them easily. Yeah, that's not the point. The point is to be able to take a custom and make everything custom, whatever you want by yourself. And I'm going to show that, even though you can do this easier with built-in stuff. So what we're looking at here is a dots component that has just one value selected. And I think, as far as I know, you can only have one value in this type of component. But it's a normal dots component still. But it's tagged as a material property, and it gets a name and a type, and these two types needs to match. And that means even if you have like an actual integer here, you still need to, if you would want to have an integer here, it would still need to be a float. You can't push in anything else than what you're seeing in this list, because it's going to the GPU, and GPU don't care about any integers. But you can store an integer inside of a float. Obviously, it's just you don't use the decimal points. Anyway, this material property that will indicate that this, wherever any entities that owns this component, that value right here will be exposed on the GPU in the shader via this name. That's the simplified version of looking at it. So if we set in our gameplay code, set this selected value to 1 somewhere, that means that in the shader, when we are drawing that component that owns this, that the entity that is drawn, we will in the shader be able to pull out that value 1. And we're going to use that for selection. Let's go. This will mean that we want to install shader graph. I just realized, is shader graph available outside of HDRP? I don't remember. I use HDRP on my other project where I use this all the time. Let's see here. Let's see if I'm gonna have to walk back on this a little bit and figure this out. Shader graph is already installed. Alright, never mind, doesn't matter. So let's create shader. We are in HDRP. That was 2 weeks ago I think I did the last stream, so I've forgotten about that. So lit graph, that means lit, yeah, you can, normal shaded thing. Laser bot health health in dot. Damn it, I can't come up with a dot. Yeah, it's this thing. So, and let's laser, not laser. Maybe it's with a S, I don't remember. I'm not an English speaker, native English speaker, so you have to correct my spelling. So here we have a shader graph. Some people might have worked with it before, some might have not. So we're gonna make it easy for ourselves, because this straight out the gate works quite well. It's just that when we do it like this, we won't get access to pushing in like all of the different values. You need to like actually manually make you able to never mind, it's, you're gonna see. So we want to put in color, because fun to have a color, right? That's nothing special about that. And let's take this and pull it in there. So this is exposed, so that means that when we create a material from this, we have, and we save it obviously, we get this color at the exposed value properties. And that's more or less what we're going to do with that. And then let's add a float, and vector1 is the same thing obviously, and let's name it mission. Wait a minute, this is with 2 M's, I don't remember. Anyway, no, it's not with 2 M's. And now comes the fun part. This thing, this name here, that's the thing we can have here to reference it. And hybrid instance experimental. Come on. There we go. Let's save. And that means that any entity which is rendered via the DOTS hybrid renderer and owns one of these, Unity will automatically push this value into this emission. So let's do like this. We can actually mission color like that. We can take them in better order, and let's do something like this. Multiply and multiply, and then pull it into emission. So that should be enough, and we can have a color red. Now let's have it green or something, and then when it's selected, have it red. That should be enough. And it's only emission that it's hybrid instanced. That's part of the thing that's really important. Well, this connection, like obviously you can set whatever you want through the material property in normal Unity. That's easy. And this might not look like magic, but to me it's a little bit magic, because this is automatically instanced, which means that it's like the best way of drawing a lot of things with the same material but different properties in the material. So let's save that, and that should be enough actually. And we can, oh, color should be actually white. That's much better. All right, this one is, I'm just a little bit confused why this is still black, but it's, yeah, that's the reason. Never mind. That's good. Multiply in emission, have that color white, emission color, blah 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 blah. That looks, everything looks good, and selected is, it has the right name. So let's exit out of that, and let's make this thing on his back have this material, right? So we have laser bot health dot. So now it's white, because that was our original value or default color. And let's apply him, and now we're gonna hook this up. So here we have the entity which will be generated from this conversion of that object. So we can just do DST manager. This is the entity manager. I don't know why they name it the DST manager. And then add component and pull in this health light object. Wrong object there. So now we add this component to this entity, right? And we want to have a reference to this entity, because remember, our unit is one entity. Our thing on the back is another entity. and they don't really know each other, don't know it about each other outside of the transformation system, which keeps them in the same place. Other than that, they don't know each other at all right now. So let's call it health dot for now. That sounds good. So we're gonna add a reference to it. Reference is the wrong word, but like, so it knows about it. You know, entities are not references. Well, and not technically, but in practice they are. Or maybe the other way around. Never mind. I'm getting sidetracked. Add component data. That's the difference between just making sure it has the component in default values and or adding the component with some specified values. And this is the thing we want to add. So health dots here, like that. Status indicator, yeah. Status would be a good, yeah. God damn it, that's a better name. Indicator, yeah, that's right. Status indicator material prop. It's a little bit long name actually. I don't really like it, but screw it. And then we can make this the other name as well. Let's reload that. So now we need to push this out to that. It's gonna be quite easy actually, but it's hard if you don't know how you should go about this. Let's just make sure that he has the new thing that we call status indicator. Apply. So when do we know he's selected? We know that right here. What do we know more? We know who it is. And he knows about his status indicator. So what we can do is that we can write to that status indicator, but we are in a parallel thread. That means that we can't write directly to it. Unity won't allow it, and that's very good. That's one more textbook race condition problem that would happen. So what we want to do is we want to record that and then write and then delay the write of that data until later. And so now it's a little bit tricky, but I'm going to try to explain this. So imagine we are crunching all this selection data. We find our bot that we want to highlight, and we know which entity is responsible for highlighting, which one we want to set this material property value on. But we can't do it in this box. But we know that after a certain point in the frame, it's going to be like a pause. All right, let's take a new breath, and in that breath we can make adjustments to everything. That's this thing. End initialization entity command buffer system. Also super long name, not my fault, Unity's fault, but I think it's good actually. So this runs whenever the initialization system group is over, and we can be sure that everything that happens inside of here is done by that point. So what we want to do is create a command buffer. New entity command buffer, and then it's gonna look maybe a little weird. Temp job dot to concurrent. That's a trick one. So this means that we are making an entity command buffer, which records our modifications to entities, but we're making a concurrent version of it, which means that we can actually do this on several threads in parallel. And the normal command buffer will not do that. It will require you to do it in one thread. You can do it in run, and run is bursted and fast and everything, and it's good. But if you want to do it in a scheduled parallel, then you have to do it with the concurrent. It will warn you if you try to. So let's do it like this. Let's create an instance of this. I'm just thinking here. Variable indication equals to 0, and then if selected. If it's selected, then we set it to 1. Indication. Very off in the spelling today. We do like that. So now we know, and then we want to write this to our entity. So we take the command buffer and we said set component, and now it requires a job index. This confused me like shit the first time. It's I don't think a lot really happens with it. It just makes sure that it happens somewhat in the order that you want it to do. I am not exactly sure what it does in the background, but the proper way of doing this is by putting the entity in query index inside of it. This will be, 0 to however many objects you iterate through, and it will not skip a number. So this will just order the instructions in some way. So we add this job index, and then we say data dot status indicator. So that means that we are assigning this component to this status indicator that we already fetched in the conversion situation. And then we are pushing in a new, this is dots with struct, so you can't like write the existing value. You don't have you can, but you should not even know about the existing value by this point basically. So we just push in a completely new component with a new value here. Selected indication, this float value. So this means that we record setting selected value, the one we looked at before, to 1 if we are selected. We record that and we say set that to this entity right here. But when is this gonna happen? We just created a command buffer. And straight after here, if we took a playback here, applying the buffer, applying the command buffer to all the entities and making all the adjustments, that won't work because this haven't even run by that point. So we need to delay it, and we could do something like give this system which runs in the next part of the frame. We could give that this command buffer and said, when you are running, everything is done. So you're allowed to do this command buffer playback. But Unity has a better way of doing this. So in each of these things where it's like between parts of the frame, so between initialize and update, and then update to present, these 3 different chunks of frame updates. So between those, you have the possibility to execute a bunch of command buffers. So create command buffer. I'm gonna explain that a little bit better in a few seconds. Yes. So this will work right now, straight up as I am doing. So what this means is that this system is running after this, like I said before. And by calling this, I'm just basically saying to them, create a buffer for me, keep track of it, give me a copy or give me a reference to it, and let me fill it in with stuff that I want to execute. And then when I'm done with it and you are running at your part of the frame, then I'm gonna be done with it and you can execute this command buffer for me. That's it. That's what's happening. And ECB and it's just the only thing you need to keep track of is what entity command buffer system runs where in the frame. So after initialize, after simulate, or after present, there's a lot of different places, and depending on when you are scheduling your job and when it's going to be complete, you're going to want to have different ECB systems in this frame executing your command buffer for you. I realize this is tricky to explain, so but this should be enough actually. This might sort of work straight up right now actually. Maybe. I just realized that I think I've written all the code that I need. Probably gonna be something where it screws up. I haven't even tried and tested my shader yet, so yeah. No errors, so you know that's one thing. Let's deactivate our big, or select, make that really see-through and see if it doesn't seem to be doing much right now, which is strange. I'm gonna make sure my my bot actually works. This thing actually works. Oh no, it doesn't. Oh, it needs to be really high. So you can see here when I drag up the emission, it's just starting to get a little bit red. So let's make that like 1,000 instead. So right here when we're setting that indication value, let's make it 1,000 and see what happens. Maybe that will do it. I'm really curious. You know what, before we do this, I know everybody's want to see it. I just want to pull down this so it's our selection square, so we don't need to mess with it after we're done, after we're sorry. I know the selection square should be something else than a semi-transparent white box, but who cares? It works right now. Yeah, it works. But it's really hard to see. So let me show you. Ha! I'm so happy this works on sort of the first try. So if we take this game view and push this over here, and then we have all of these guys, and you can see how they're. How about that? So that means that every single unit is going through this this paralleled thing where everybody's like, am I inside the square? If I am, push this value over to this component, the material property component, and then Unity sees this and says, oh, this component is marked as a material property and it has a name. So let's take that value and let's assign that value to a name on a value in the shader. Oh, there it is. Let's assign it, and then when the GPU comes along and like, oh, here's emission color, emission strength, or whatever emission I think I named it to. It's 1,000. Let's make them emit light. That's so nice. If we for fun add volume, I know I'm in play, so it doesn't really fly that well. If we take this is post processing in HDRP. So if we take post processing, where is it? There we are, and set bloom, and then in threshold, maybe we can. We should just make this not just change the emission color. So let's just rename this to something else. So
well, we can still have it selected, but let's rename it to, this one can be named selection as well, selected, and then we can do, we can name this selection color. Let me make this bigger so you guys see better. I have a good idea. And after this, I will go through a little bit of my future plans, but I'm not gonna stream for 3 hours this time. My throat just doesn't handle it. And maybe it's more fun to see it in a little bit more chunks. I believe most people don't have really the mental capacity to look at me for four freaking hours. I wouldn't want to, or something. Selection color, so it goes in here and it just makes the mission stuff work, right? So we can do something like this instead, where we take the color and we lerp that between between selection color and normal color based on the selection value. So that should probably do the whole thing for us and make it much easier to see what the hell is going on. Selection color, blah blah blah. That should be nice. Color, nothing special here. Save. Go back to game, and then we don't need to have it 1,000 because now we're just looping between two values. We're not setting any emission. I mean, we're gonna add emission eventually because it's nice with some stuff lit, but it's not really necessary right now. You know what? Just to make it clean, I'm gonna comment out my log because that's stealing a little bit of my performance and I don't want it to do that. Like that. I think emission is physically based thing. It is in lux or lumen. Yeah, good point. Skasam, you sound like a professional. You keep pointing out stuff to me that I should think about, or you know. There you can see. So, and we can even make this even more clear by, you know, having this selection thing even more dim, and then go back to the maximize, and then I think that proves my point. That is a pretty good performance wise. And now you could see how I could just like select all this and then like, oh, go here, and it will probably work. So, but yeah, Skalsam has a really good point. Emission is in a completely different thing than 0 to 1, and it's I probably is in Lumen or something. But the annoying part is I think the lit shader does trick things, because if you're working with lights as a normal light in Unity, then you have the option to set it to Lumen, Lux, or EV100, I think they named it to. And I don't really know how they relate to the actual emission value inside of shader, but it's probably just straight up like Lumen or something, like you said. Fancy as fuck. Cheers. So, I think I'm doing myself a disfavor if I push this much further right now, because my head is getting a little bit slow. And I think, to be fair, the other thing, the two previous time, I got stuck on a single issue. Like the first time, I don't remember what it was, but the last time it was the damn selection box, which I just couldn't get the hang of, and like it still doesn't work unless you're doing from the lower left to the top right. Anyway, so I'm gonna probably end it here, but let me explain what my thinking is of where we're going with this next. So probably off stream I will make this selection thing work in every direction and make it a little bit nicer looking, unless somebody really wants to see that, but it's just fixing stupid things and writing annoying code, and it's going to be available through the GitHub anyway, so you can check it out later, and it's going to be commented enough. I hope I have the time and energy to comment everything enough. But anyway, so I'm going to fix this so it works in every direction, and then next time I'm probably going to add a scroll so you can scroll in and out and make this maybe a little bit
we disable that. Make the RTS camera scrolling a little bit better, and then, because next step in making this really cool, it's having them be able to move, but it's a little bit tricky to make all of these move, and I don't really think that's the right way of doing this. It's not necessary to make them move like bunch of swordsmen or whatever, or robots in an army. I think it's more fun to make a void system out of this, and that's what I thought about the first time as well. So void system, for those who doesn't know, is like basically how fish swim in a stem. No, that's a Swedish word. Yeah, when a bunch of fish swim together, they keep distance to each other, but they are still together in a big chunk. So void system is like follow the group, keep your distance, and go in the same direction as the general, as everybody else, sort of, or in the general direction that everybody else is going. And so one of those things is that accumulating the midpoint, that's trivial code-wise, but performance-wise is not really trivial. So finding the midpoint of every one of these that's a dots problem that's just waiting to be solved. And then we have the keep distance. So the distance thing is tricky unless you spatialized fragmentation of their positioning. And for those who doesn't know that, probably people know some sort of version of this, but maybe don't know the terminology. I don't even know if my terminology is the correct one. That's what my old colleagues called it. So it means that splitting this whole thing up in grids, in a grid of maybe 10 by 10 units or 1 by 1 unit or something like that, and then having like every robot telling this grid system, I'm here, and then it gets registered in a specific square or a specific grid point. And then when you are trying to find if you're too close to anybody else, when you're trying to do that, you don't need to check with everybody else. You just check with the squares, with the square you're in, and the squares nearby you. So that's what I call spatialized fragmentation. And I've done it a few times for different purposes, and this is perfect time. And I think you could probably do this in some way with dots with other approaches, but I think it's fun to do this with that approach, and it's going to be probably super fast. So we're going to be able to take all of these guys and just like right click over here, and they're going to move like in a big, I don't know what to say. I'm gonna stim in English, Swedish, shoal. Can somebody in the chat correct me? Oh, an octree, yeah. School of fish. There we go. That's weird to me that you guys are calling it school of fish. We have a word in Swedish called stim, S-T-I-M, and that's like the literal word for just a bunch of fish together. Skalsam, an octree. You mean like is that a different word for spatialized fragmentation? Because isn't that like, you mean like the actual data structure? Because the version I'm implementing is not going to need a specific data structure. It's just going to be like a big long array of buckets, and you can register yourself as a entity inside of a bucket, and that bucket is going to be a grid square. Yeah, that's what I thought. I don't remember I worked with octree before, so that's what I thought it was, but I'm just making sure that it wasn't a different name. It doesn't sound like anything but a data structure. So anyway, I'm gonna do that. We're gonna make it work like a school of fish, and it's gonna probably look awesome, hopefully. And sort of the game design idea of this is like, the micromanaging thing where you can't really trust that they're gonna move in a coherent, perfect way and place themselves very well around the enemies. They're gonna move, and they're not gonna move into each other, but they're still gonna be like a little bit random. And then you're gonna have to like select them randomly all over the place and make sure they like surround the enemy they want to take down and everything like that. And I think that's a nice gameplay idea. So we're gonna do that, and it's gonna be quite cool, I think. That's probably it. If you have any questions, I'm all ears, but I'm gonna end the stream soon. I hope this, if anybody want to comment, is this like properly impressive for the performance wise? Like I said, this took under a millisecond to do this calculation. Like the profiler says like, yeah, nothing. If we take a look at it again, that's our selection code. When we zoom out to the whole frame, it's just a boop, nothing. Everything else here is rendering. So yeah, so I think it's really good. I just want to make sure that I have the LaserBot, all of the different materials marked as. Oh, that's interesting. The materials are not marked as instanced. That's why the performance is so bad. Actually, we're gonna just make that happen, just quickly, because it's gonna be nice. So let's just make them enable GPU instancing. I don't know if this is something you can do somewhere else. This is one part. The importing of different materials and stuff is not really my strong suit. So let's just go with it and see what happens. So this one is correct now. The laser should be the new one, dark material, main robot mat, and the laser. This is probably the slowest way of doing it, but we're gonna be done soon, and we're gonna see if it's better performance. I don't know. And here we have a good example of where the conversion system will split everything up. Maybe I'll show that in another time if anybody's curious. But so let's see if that makes it better performance-wise. That's really. I obviously dragged my the wrong the wrong thing. I know it didn't actually matter. It's the same. I think the instancing is something strange with it. So we shouldn't put too much focus on the instancing part not working properly, because it's like doesn't really matter. Because we saw in the profiler that the actual selection code like takes nothing. I just need to fix this. There. Oh yeah. That's why it's weird. Now we go. And there we go. So all of that applied, and all of these guys are instanced. Yeah. So something is strange with instancing. Maybe it doesn't work properly. But in the profile it said like our selection took under a millisecond, which is perfectly fine. So that's it. I hope you guys had learned something. I did, and I'm gonna make it a struct or a rect the selection thing, and I'm gonna make sure it works in every direction and clean up the code and then commit it to GitHub. And then next time we're gonna do a void system out of this, and I'm excited about that, because the result of that, it's gonna look nice, and it's hopefully gonna fly a little bit better by promoting this on the subreddit. The subreddit is strange. Some stuff they love and some stuff they don't care for at all. But I think the void system is gonna look so cool that I can like get some more people maybe to think to be interested in this by showing off the void system. So that's nice. Anyway, thanks for watching. See you guys next time.